He'll be like,
All right, so I don't have tests to return to today. I will. There's a chance I might send out grades today electronically. That's very.
Thank you very much, Billy.
So there's.
You're fine. Don't worry.
There's a there's a chance I'll send them out electronically today, and hopefully tomorrow or Thursday. But with people being sick last week, it's actually been a challenge to get all the tests taken. So I will do my best to get that to you as soon as I can. So as you might remember from last semester, after we learn the fundamental understanding of the definite integral, we need to learn some rules. So, let's learn some rules. Do I have what? Nope. Sorry. Let's learn some rules. No calculator. Do I have a packet? She wants me to type up 100 rule problems, and I won't. All right. So the first thing I want you to notice is that integral sign is not a definite integral. It doesn't have upper and lower limits. We call this the indefinite integral. And the difference between the definite integral and the indefinite integral is the definite integral is a number. There's a number associated with the definite integral. The indefinite integral is associated with a function. It means, what is the rule that this is the derivative of? Another way of saying it is, it's the antiderivative. All right. So the indefinite integral is asking you, 3. What is the antiderivative of 3? In other words, what's the rule that 3 came from? Say it loud and proud. 3x. Does that work for people? What else? Yeah. What else could it be?
3x plus 1.
Yep. 3x plus 1. Come on, there's some more.
Plus 2.
Plus 2. Yeah. All right. So we say plus c, where c stands for any constant. And just because we say plus c doesn't mean c can't be negative, right? It could be plus -3, right? So this takes care of any constant that you'd add or subtract. Is that okay? All right, let's generalize that. The antiderivative of k dx, where k is some constant, or some parameter. What's the antiderivative of k? Kx plus c. You learned your first rule. There you go. So we call that the antiderivative or the indefinite integral. Okay? In other words, if we needed to evaluate the definite integral of k, we could also think about the function kx. So let's just think about for a second, go back to 3. If I had the definite integral from 0 to 2 of 3 dx, what I could do, instead of trying to figure out how much area there is under that function, I could actually figure out the antiderivative, or the function which 3 is the derivative of. And that would be 3x. And I'm going to use some new notation. I'm going to use that bar and put 0 to 2. And that bar means plug in 2 and then plug in 0 and find the difference. So if I plug in 2, I get 3 times 2 is, plug in 0, I get, so the answer would be 6. And if you think about it, that's exactly how much area is under the function 3 from 0 to 2, right? Isn't that just a 3 by 2 box, which is 6? So this says what's the area. This says what's the difference in functional values. This uses the function 3. This uses the antiderivative 3x. All right? Morning. Did you sign in? Did you sign in? Yeah. Good. All right. What happened to the plus c here? We sort of just forgot about it, didn't we? what would have happened if we actually did 3x plus c from 0 to 2? When we plug 2 in, we get 6 plus c. We plug 0 in, we get 0 plus c. What happens to c? They're going to cancel out. Okay. All right. How about what is that the derivative of, or what is the antiderivative of x squared? David? Did you get it? Good. That plus c is going to be the difference between right and wrong on the gateway test. Good. All right. Let's do a few more of these. Julia? What? Did she get it? I think so. Good. How about
x to the 8th plus c.
3/8 x to the 8th plus c? Did Dan get it? I think he did. All right, so David, Julia, and Dan, I'm feeling pretty good about that. Let's try to generalize all this, though, so that everyone has a rule, right? So that we're not just sort of guessing. If you have a x to the n, where a and n are some parameters or some constant, what's going to be the rule for doing the antiderivative? We knew a rule for the derivative. For the antiderivative, Alicia? You want to stay with it? You're pretty close. And you just need to fix one more small thing. Well, all right, it is plus c, you're right. In the denominator here, I don't think it's going to be a divided by n. I think it's going to be n plus 1, okay? So here's the power rule in reverse. It says increase the exponent by 1, divide by the new exponent, right? The other one was multiply by the exponent, decrease the exponent by 1. We're doing that in reverse now. We're increasing the exponent by 1 and dividing by the new exponent. All right? Yes? All right. But wait, there's more. Let's do... Let's just try for a second. 1 over x is thinking that he or she is x to the negative 1. If I increase the exponent by 1, I get x to the 0, which is 1, but then we have to divide by... Oh, well, good. I was going to say, this is a problem. You can't use the power rule, the exponent rule, to find the antiderivative. The antiderivative of 1 over x is the ln of... Now, I'm going to put the absolute value of x in there. It protects the function. It just reminds you that whenever you have the natural log function, you can't take the natural log of negative numbers. The function's not defined on that domain. So by putting the absolute value there, you're actually saying, look, I know 1 over x may have had a domain from negative infinity to infinity, but when we take the antiderivative, we're only talking about defining the natural log of x for values that it can be defined for. So that's what the absolute value does. It protects the function, the natural log function. All right, cruising along. Let's see. So you have 1 rule, you have 2 rules, you have a 3rd rule. How about... Yeah, gotta love that rule, right? So here's what's going to happen. It'll mess you up on the first quiz, and I won't take full credit off on the first quiz. I'll take a point off every time you forget the C on the first quiz. And after you mess it up on the first quiz, you'll be good. You'll be like, all right, I'm not going to forget to do that again. That was such a waste.
Sin x plus negative sin.
Positive or negative? This is the debate we have. Is it negative? Negative or positive? So this is sort of like an Algebra 1 class when your teacher always said, check your work. We can always check our work. If the function's sine x, what's the derivative of sine x? Cosine. That's where that is. So the antiderivative of cosine x is sine x. All right? Okay. Let's try this one. Oh, yes, I did. All right, so we should try the negative here. So the derivative of negative cosine would be negative sine, which would be positive sine. That does work. Let's see. Are we ready for a million examples? I think we are. All right. So I want to tell you, when we were doing the derivative, I think we learned maybe 1 or 2 rules every day. Because we've done everything forward, I've just given you 6 rules that we're going to do backward, right? So it's like we already know a lot of the rules. Now it's just about getting practice. So this chapter is actually a little shorter than the derivative chapter, taking derivatives, but it's because we already know what going forward's like. So now it's just sort of going in reverse. So it's like if you pass your driving test going forward, then we feel okay about having you back out of stuff. Like, all right, so we're going in reverse. Let's do a million examples. All right. Now, sometimes we'll use the indefinite integral. Other times we'll just say find the antiderivative. They both mean the same thing. All right. Who's up for number 1? Morgan.
Oh wait, never mind.
Courage for the deed?
Okay. Can I call it?
Yeah, sure. You don't have to do it.
5, 6, x to 6. I mean, 5 halves x to x squared plus 3.
Yep.
Yeah.
All right, so we increase the exponent by 1, and we divide it by the new exponent. Okay? Morgan, you want to try number 2? Okay. Julia, calling someone?
True. 1/3 x cubed plus 1/2 x squared.
Good. All right, so the antiderivative of a sum is just the sum of the antiderivatives, right? That's okay. You're fine if we take antiderivatives of sums or differences. You're going to have some problems, though, if we talk about quotients and factors, right? As a matter of fact, if we just go over here for a second, all right. All right, pretend you didn't see that for now. Let's get that out of the way just for a second. Okay. If we had 3 e to the x. Can I show you the wrong way to take the antiderivative? The wrong way would be to say, all right, the antiderivative of 3 is 3x. The antiderivative of e to the x is e to the x. That's not the antiderivative. Well, all right, so this is the thing. If we have a product, we need to think about maybe that it's the chain rule backward. Isn't that now? If it was the product rule backward, what would it look like? Something times something plus something times something. And we're not actually going to do the product rule backwards. The product rule backwards involves a strategy called integration by parts, and you may very well learn that next year in calc class. We're going to have enough strategies to keep us busy, which is fine. We are going to learn how to anti-differentiate the chain rule, though. And the chain rule is just going to be something times something. Now, if this was the right answer, if it was 3x times e to the x, we would have to do the product rule to get this, and we obviously didn't do that. As a matter of fact, let's skip down to 4. What is the antiderivative of 3 e to the x? It's not as complicated as we may have thought. E to the 3x?
Plus c.
What's the derivative of e to the 3x? E to the 3x times 3. That did not work. 3e to the x? The derivative of 3e to the x is 3e to the x. Yeah, that worked. Okay. So actually, we didn't need any sort of fancy multiplication to undo this one, right? So multiplication, if it's straightforward, it might be fine. If it's not straightforward, it might actually be a little bit challenging. Like, if we go back to this one, that one's going to be pretty hard. And we shouldn't do that today. Okay, 3. Morgan. No. I'm glad you said it, though, because people were thinking it. It's tempting to think that 1 over anything is always ln. Not always, because what's this guy thinking? X to the negative 2. I don't have a problem with x to the negative 2. So the rule for, if I have an exponent, this is where one of you calls something. Go ahead, Morgan. You went the wrong way. I understand what you're thinking. You're thinking, hey, x squared is like x to the negative 2. But we need to increase the exponent by 1. So this is actually, this is harder. You should have picked number 2. You would have been fine with 2. So it's going to be negative 1 times x to the negative 1. Because when you take negative 2 and increase it by 1, that means you add 1 to the exponent. That gets us negative 1. Divide by the new exponent, we get negative x to the negative 1. And then we want to remember plus c. Do you want to ask a question on 3? 3 is very similar to 1 and 2, but it's filled with traps. Conceptual misunderstandings. Arnie, I think your calculator will do all this for you. I also am fairly confident that if you look up something like antidifferentiation or indefinite integral on the web, you'll find websites that'll actually do the answers for you. Like you type in 1 over x squared and it will tell you negative 1 x to the negative 1. All right. Number 5, Morgan, call on someone.
So that's the same thing as the sum of x plus x to the negative 1.
All right, so this is x squared over x plus 1 over x. Oops, I forgot my dx, sorry. Ooh, here too. My gosh, poor Bad math teacher, sorry. Which Drew said x squared over x is the same as x. 1 over x is the same as x to the negative 1. So, as a quotient, we didn't have a rule to do it. But with a little bit of algebra, Drew gets us into a position where we can do this problem now. That sounds familiar, right? From like first semester, there were problems that if we did a little algebra, it made it a lot easier. Here it is. All right, go ahead.
So that equals 1/2 x squared plus the element x plus c.
Yep, and I'm going to make sure I put absolute value signs around that. We're going to do 5 more, but do you want to ask some questions? All right. Oh, sorry. All right. You want me to scroll down, I guess? Y'all scared me. Ooh, that one's good. We didn't do that rule. I'll save that for a little later. That is. It's a very bad 5.
Just check. 5e to the 5.
Yep. No, maybe that's too hard. All right. Some of them are going to be a little hard. I'm all right with that. Drew, calling someone.
2/3 x to the 3/2 plus c.
All right. Talk to us, Sam. People
Okay, so that's the same as x to the half.
Okay. So x to the half, you need to increase the exponent by 1. So 1/2 plus a half is 3/2. And then you need to divide by 3/2. Well, dividing by 3/2 is the same as multiplying by 2/3. That was well played. Nice. All right, Sam, calling someone. Wow, no one.
Dan's going.
Okay. So, 25?
No.
I don't know.
Well, all right, let's start with this piece.
Alright, plus e to the x.
And then plus
C.
c. All right, so come on, courage for the deed. Let's try something, Dan.
5e to the 5x.
All right, so if I asked you what's the derivative of 5e to the 5x, the derivative of 5e to the 5x would be 25e to the 5x.
So it's just e to the 5x.
So if it's just e to the 5x, the derivative of e to the 5x is e to the 5x times 5. Where did this 5 come from? It's the chain. It's the chain. So that's pretty hard. Because you have to see like that this is the chain, and then once you see it, you almost have to like ignore it. Right? Nice. You stuck with it. All right, calling someone, Dan.
Alicia.
You got it. All right, Alicia, calling someone.
Would that be 3/2 cosine of? Wait, no. I'm getting confused because in my mind I keep taking the derivative of that function. getting confused.
You want to try again, or you want to?
Now,
You sure?
Yeah.
All right. Get a little help.
anybody?
Kelly's thinking about it.
I guess so. Is it negative cosine 3x
Negative cosine 3x.
plus 8?
All right. So the derivative of negative cosine is going to be sine of 3x. Where'd this 3 come from? It's the chain.
Oh,
That's brutal, huh?
The ones like I feel like that won't be difficult later on. These are just like seeing. Okay.
You heard it here first, folks. Dan's fine. All right. This one's hard, and I didn't give you the rule for it. Yeah. I suppose we probably could have done. I mean, we did the e to the x rule, but we didn't really do the any other base to the x. I mean, let's just, if you want, we could refresh our memories. If y equals like 2 to the x, the derivative would be. Okay, so.
oh.
David, you want to take a shot?
Would that be? No, wait, never mind. Never mind.
Well, I mean, look for some patterns, right? There's something's the same in both of them, right?
I'm just gonna throw it out there. 10 to the x over the ln of 10.
Yeah. Perfect. Right? So David's taking what we were doing before, taking the derivative, and he's reversing that. So instead of multiplying by the natural log of the base, you divide by the natural log of the base. Oh yeah, plus c, thanks. There are going to be some people, like in this class, who are never going to forget the plus c. And you'll find out who they are over the next few days, but they're going to be the ones, every time I forget it, they're going to be like, plus c. And they're going to be the ones that are never going to forget on the quiz or tests. So, way to go. I think Julie and Alicia are already on track. Yeah. Yes. Yes. As long as you're taking the antiderivative, because the plus c means it could be plus 2, plus 5, it really takes into account any of that. Does anyone? It's not a variable. It's a constant. If you wanted to put plus r, because r for Rachel, you could do that. People would think it's a little weird. Most mathematicians are accustomed to plus c because c stands for a constant. But if you wanted to do it where you did something else and defined it as a constant, that'd be fine. There's a difference also. Sometimes it'll say find an antiderivative. And if they say find an antiderivative, well, that's an antiderivative. That's an antiderivative. If they say find the general antiderivative, that means it has to be plus c. Whoops. Do you understand the difference? Because when we say an antiderivative, that means just find one, and any one that you want. If we say find the general antiderivative, that means you have to find all of them, so it has to be the plus c. That's a good question. All right, so I don't think you're going to lose points for doing it, but I don't think it's answering the question as it's posed. It's like me saying name a state and you listing all 50 of them or something, which is fine. You definitely named a state. You just did more than I asked. All right. Does anyone have any idea? Are these periods? These are shorter today.
Does anybody know what the
All right.
performance is?
It's like Shakespeare. It's not really anything, isn't it?
All right. So, your homework 6-2A. For those of you who like rules, you're gonna like this homework. You're gonna enjoy. Oh, great! I'll spend 15-20 minutes just doing the rules backward. We're going to spend another day, so if the rules don't come quickly, that's okay, but you got to start memorizing them sooner as opposed to later. Have a terrific Tuesday. Welcome back. So good to see you all.
Rachel, do we have comedy?